Abstract. In today's highly competitive and dynamic market environment, optimizing supply chain efficiency and enhancing decision-making capabilities are critical for organizational success. This paper presents a systematic literature review, SLR, on recent advancements and theoretical frameworks in supply chain efficiency and decision-making. The review synthesizes findings from 150 peer-reviewed articles published in high-impact journals indexed by Scopus, covering the period from 2010 to 2023. Following the preferred reporting items for systematic reviews and meta-analyses, PRISMA, guidelines, articles were systematically selected, analyzed, and categorized into key themes, including 1. Data-driven decision-making, 2. Digitalization and technology adoption, 3. Lean and agile supply chain paradigms, 4. Supply chain risk management, and 5. Sustainability. The analysis reveals an increasing emphasis on big data analytics, Internet of Things, IT, and artificial intelligence, AI, as critical enablers of efficiency, with robust evidence indicating their impact on improving forecasting accuracy, inventory management, and real-time responsiveness. Findings also underscore the importance of integrated risk management frameworks that mitigate supply chain disruptions, along with sustainable practices that align with global environmental goals. Despite significant advancements, gaps remain in the adoption of hybrid models that combine lean and agile principles, particularly in adapting to sudden market fluctuations. This review contributes to the academic discourse by offering a comprehensive synthesis of contemporary approaches and technologies in supply chain management. Furthermore, it provides practitioners with actionable insights for implementing data-centric, technology-enabled strategies to enhance decision-making and operational efficiency. Future research directions are proposed to address emerging challenges, including AI-driven predictive modeling and the scalability of sustainable supply chain practices. Keywords: AI, data-driven decision-making, digitalization and technology adoption, supply chain paradigms, supply chain risk management, sustainability. 1. Introduction. Enhancing supply chain efficiency and decision-making is a multifaceted challenge that requires integrating resilience, sustainability, and strategic innovation across various sectors. The development of resilient supply chain frameworks, such as those proposed for semiconductor distribution, emphasizes the importance of demand risk management and collaborative efforts to improve supply chain resilience, particularly in the context of Industry 4.0, FU, 2023. In the pharmaceutical industry, a smart decision support framework that combines fuzzy multi-criteria decision-making with multi-objective programming has been shown to optimize supplier selection and order allocation, thereby enhancing sustainability and resilience. Keone et al., 2023. Strategic location decision-making approaches further contribute to supply chain sustainability by balancing cost and carbon emissions, which is crucial for long-term planning and risk management. Siralertsawan et al., 2020. The flexibility of supplier networks, especially during disruptions, is critical, as demonstrated by models that optimize supplier selection and order allocation to minimize stockouts and procurement costs in the PPE supply chain. Chauhan et al., 2023. The COVID-19 pandemic has underscored the need for supply chain integration to enhance resilience, flexibility, and innovation, which in turn improves business performance. Siagian et al., 2021. Sustainable Supply Chain Management, SSCM, strategies are pivotal in improving operational and financial performance, highlighting the need for integrated approaches that align with overall business strategies. Librand, 2022. Addressing supply chain uncertainty through strategic alignment and contingency planning is essential for minimizing performance impacts. Semengansong et al., 2012. Concurrent optimization of product design and supply chain configuration can lead to higher profits and better visibility, emphasizing the importance of integrated decision-making processes. Gokin, 2010. The Great 3RS framework offers a comprehensive approach to reforming global supply chain management under pandemic conditions, focusing on resilience, responsiveness, and restoration. Choi, 2022. Finally, sustainable supply chain system design and optimization are crucial for balancing economic benefits with environmental preservation, thereby enhancing both profitability and ecological impact. Turkey and Rezk, 2019. Collectively, these studies highlight the critical role of innovative frameworks and strategic integration in enhancing supply chain efficiency and decision-making across diverse industries. 2. Theoretical background. The study of supply chain efficiency and decision-making is underpinned by various theoretical frameworks that explain the complex interrelations, structures, and dynamics within supply chains. These frameworks draw from operations management, systems theory, data analytics, and risk management, among others. This section reviews the foundational theories and models that are most relevant to enhancing supply chain efficiency and decision-making capabilities. 2.1 Systems Theory in Supply Chains. Systems theory provides a foundational perspective for understanding the supply chain as an interconnected network of entities that function together to achieve shared objectives. Forrester, 1958. In the context of supply chains, systems theory emphasizes the importance of integrated planning and coordination across suppliers, manufacturers, and distributors to achieve optimal performance. Christopher, 2016. Each subsystem within the supply chain, such as procurement, production, and distribution, relies on the seamless flow of information and resources, underscoring the importance of real-time data for coordinated decision-making. Ivanov, Dogwi, and Sokolov, 2019. Systems theory thus supports the rationale for adopting integrated, data-driven approaches to enhance supply chain responsiveness and adaptability. 2.2 Transaction Cost Economics, TCE, and Efficiency. Transaction cost economics, TCE, is central to understanding efficiency in supply chains, particularly in the context of decision-making regarding outsourcing, supplier selection, and partnership formation. Williamson, 1979. TCE posits that organizations seek to minimize the costs associated with exchanges, including search, negotiation, and enforcement costs. This framework explains why companies may opt to outsource certain functions or choose strategic suppliers to reduce operational costs and leverage partner expertise. Carter and Hodgson, 2006. TCE also provides insight into how technological advancements, such as blockchain, reduce transaction costs by increasing transparency and trust among supply chain partners. Saburi et al., 2019. 2.3 The Resource-Based View, RBV, and Supply Chain Capabilities. The resource-based view, RBV, of the firm highlights how organizational resources and capabilities contribute to competitive advantage. Barney, 1991. In supply chain management, this view focuses on the development of capabilities that support efficient and responsive operations, such as data analytics, automation, and supply chain visibility. Hitt et al., 2016. By leveraging unique resources, such as skilled personnel, advanced technology, and strategic supplier relationships, firms can achieve superior supply chain performance and decision-making efficiency. Studies have shown that resource-rich supply chains exhibit greater resilience and flexibility in responding to market changes. Gunasekaran et al., 2017. 2.4 Decision Theory in Supply Chain Management. Decision theory provides a structured approach to making optimal choices in uncertain environments, which is a common scenario in supply chain operations. Kahneman and Tversky, 1979. In particular, utility theory and probabilistic decision-making models help supply chain managers evaluate alternatives based on expected outcomes and associated risks. Decision theory supports the application of analytics and machine learning algorithms in forecasting demand, managing inventory, and allocating resources efficiently. Studies have highlighted that the use of advanced decision-making models reduces forecasting errors and enhances planning accuracy. Boyer and Swink, 2008. 2.5 Lean and Agile Supply Chain Paradigms. Lean and agile supply chain paradigms provide contrasting approaches to achieving efficiency and responsiveness. The lean paradigm, rooted in the Toyota production system, emphasizes waste reduction, process standardization, and continuous improvement to achieve cost efficiency. Womack, Jones, and Roos, 1990. In contrast, the agile paradigm is designed for responsiveness and flexibility, allowing firms to adapt quickly to market changes by maintaining a high degree of supply chain flexibility and responsiveness. Christopher and Twill, 2001. Recent studies have examined hybrid legal models that combine lean principles with agile responsiveness, enabling firms to balance cost efficiency with market adaptability. Naylor, Naeem, and Berry, 1999. 2.6 Supply Chain Risk Management Theory. Supply Chain Risk Management, SCRM, is an essential framework that addresses uncertainties and risks that can disrupt supply chain operations. Jutner, Peck, and Christopher, 2003. SCRM theory provides a structured approach to identifying, assessing, and mitigating risks, whether due to supply-side disruptions, demand variability, or external factors like economic and geopolitical shifts. Pettit, Fixel, and Croxton, 2010. The theory emphasizes the need for proactive risk identification, contingency planning, and the development of resilient supply chain structures. With the increasing frequency of disruptions, SCRM has become critical to ensuring continuity and efficiency in supply chain decision-making. Ivanov and Dogwi, 2020. 2.7 Big Data Analytics and Decision-Making in Supply Chains. The integration of big data analytics into supply chain management is a transformative approach that enhances decision-making accuracy and efficiency. Analytics-based frameworks enable real-time insights and predictive modeling, empowering managers to make informed decisions on demand forecasting, inventory optimization, and risk mitigation. Chai, Olson, and Shu, 2014. Key studies have demonstrated that data-driven supply chains can respond faster to market demands and minimize stockouts and overstock situations, thereby improving efficiency and customer satisfaction. Shaner and Spear-Piro, 2015. The theoretical underpinnings of data analytics in supply chains are supported by data processing and predictive modeling theories, which emphasize data integration, analysis, and application for superior decision-making outcomes. Waller and Fawcett, 2013. 2.8 Digitalization and Technology-Driven Supply Chains. Digitalization theory highlights the role of emerging technologies, such as the Internet of Things, IT, blockchain, and artificial intelligence, AI, in enhancing supply chain transparency, traceability, and efficiency. Bendia, Hassaini, and Brown, 2019. Digitalization enables the creation of smart supply chains that leverage real-time data for process automation, predictive maintenance, and adaptive planning. Scholars have found that technology-driven supply chains significantly improve both efficiency and decision-making by automating routine tasks and allowing managers to focus on strategic decisions. Hoffman and Rush, 2017. These findings reinforce digitalization as a core enabler of supply chain innovation and competitive advantage. The frameworks outlined above collectively offer a robust theoretical foundation for understanding and enhancing supply chain efficiency and decision-making. By synthesizing concepts from systems theory, TCE, RBV, decision theory, lean and agile paradigms, SCRM, big data analytics, and digitalization, this research paper provides a comprehensive understanding of how supply chains can be optimized. Each theory contributes unique insights into how organizations can address the challenges of modern supply chains, thereby enabling more efficient, resilient, and responsive supply chain operations. 3. Methodology. This study adopts a systematic literature review (SLR) approach to provide a comprehensive overview of recent advancements in supply chain efficiency and decision-making. The methodology follows a structured process, including the definition of research questions, systematic search, and selection of relevant literature, data extraction, and thematic analysis. The process is guided by the PRISMA framework to ensure transparency, rigor, and replicability. 3. 1. Research questions. The review is driven by the following research questions, RQs. RQ1, what are the key themes and strategies in recent research on supply chain efficiency? RQ2, how are emerging technologies such as big data analytics, artificial intelligence, AI, and the Internet of Things, IT, impacting decision-making in supply chains? RQ3, what are the major theoretical frameworks underpinning supply chain efficiency and decision-making? RQ4, what are the current challenges and future research directions in enhancing supply chain efficiency? These questions are designed to provide insights into the state of the field, highlight advancements, and identify gaps in current knowledge. 3. 2. Search strategy. A systematic search was conducted in Scopus, chosen for its comprehensive coverage of high-quality peer-reviewed articles and journals in supply chain and operations management. To ensure a wide range of relevant studies, the search terms were developed based on key concepts related to supply chain efficiency and decision-making. The following keywords were used in various combinations. Primary keywords: supply chain efficiency, supply chain decision-making, supply chain optimization. Supporting keywords: big data analytics, digitalization, artificial intelligence, IT, lean supply chain, agile supply chain, sustainability, risk management. Boolean operators and/or were used to refine search results, focusing on studies published between 2010 and 2023 to capture recent advancements in the field. Searches were limited to English-language articles to ensure accessibility and clarity in analysis. 3.3. Inclusion and exclusion criteria. To ensure the relevance and quality of selected articles, inclusion and exclusion criteria were defined as follows. Inclusion criteria. Peer-reviewed articles published in Scopus Index journals between 2010 and 2023. Studies focusing on supply chain efficiency, decision-making, digitalization, and related technologies. Papers that present empirical evidence, theoretical contributions, or case studies relevant to supply chain management. Exclusion criteria. Non-peer-reviewed papers, book chapters, conference proceedings, and dissertations. Articles not primarily focused on supply chain management or decision-making. Studies published before 2010 unless foundational or frequently cited in recent literature. The initial search yielded 650 articles, which were then refined based on these criteria, resulting in a final dataset of 150 articles. 3.4. Data extraction and analysis. Data from the selected articles were extracted systematically, focusing on key elements relevant to the research questions. A standardized extraction form was used to ensure consistency, including the following information for each article. Citation information: authors, title, journal, publication year. Study type: empirical study, theoretical paper, or case study. Key themes and concepts: main themes such as technology impact, risk management, lean/agile paradigms, and sustainability. Findings and implications: major conclusions and insights related to enhancing supply chain efficiency and decision-making. Limitations and future research directions: identified gaps and suggestions for future research. A thematic analysis was conducted on the extracted data, categorizing findings into key themes that emerged across studies. This approach allowed for the identification of patterns, relationships, and recurring insights that inform the broader landscape of supply chain efficiency and decision-making. 3.5. Quality assessment. To ensure the robustness and reliability of the selected articles, a quality assessment was conducted. Each study was evaluated based on the following criteria. Relevance, the study's alignment with the defined research questions. Rigor, the methodological soundness of the research design and data collection. Contribution, the degree to which the study contributes new insights or theoretical advancements to the field. Citations and impact, consideration of citation count and journal impact factor as indicators of influence. Studies meeting all criteria were classified as high quality, while those with minor methodological or relevance issues were classified as moderate quality, but retained if they provided valuable insights. 3.6. Synthesis and reporting. The final step involved synthesizing the findings and reporting them according to thematic areas that emerged from the analysis. Each theme is discussed in the context of the research questions, with findings organized into sections on data-driven decision-making, technology adoption, lean and agile paradigms, risk management, and sustainability. The synthesis also highlights trends and advancements in the field, practical implications for supply chain management, and directions for future research. For key findings and analysis. The systematic review of 150 Scopus-indexed articles on supply chain efficiency and decision-making revealed several key themes and advancements across emerging technologies, risk management strategies, lean and agile paradigms, and sustainability efforts. This section presents the findings organized around 5 primary themes identified in the literature: data-driven decision-making, digitalization and technology adoption, lean and agile supply chain paradigms, risk management, and sustainability. These themes reflect the most recent and impactful trends influencing supply chain efficiency and decision-making. 4.1. Data-driven decision-making. The application of data analytics in supply chain decision-making has been one of the most prominent themes. Research consistently highlights big data analytics and predictive modeling as transformative tools for enhancing accuracy and speed in forecasting, inventory management, and demand planning. Chai, Olson, and Xu, 2014. Shaner and Spear-Piro, 2015. For example, studies demonstrate that the integration of machine learning and predictive analytics allows organizations to anticipate demand fluctuations more effectively, reducing stockouts and overproduction. Ivanov et al., 2019. Key insight: data-driven decision-making significantly improves supply chain responsiveness and efficiency. Predictive analytics tools facilitate real-time adjustments in response to demand variability, leading to optimized inventory and minimized waste. Gunasekaran et al., 2017. Limitations: the implementation of advanced analytics is still limited by data quality issues, system integration challenges, and a shortage of data science skills within organizations. Wamba et al., 2015. Further research is needed to explore solutions for integrating disparate data sources into a cohesive analytics platform. 4.2. Digitalization and technology adoption. Digitalization has emerged as a cornerstone of modern supply chain management. Technologies such as the Internet of Things, IT, blockchain, and artificial intelligence, AI, have been widely adopted to enhance transparency, traceability, and efficiency in supply chains. Bendaya et al., 2019, Hoffman and Rush, 2017. IoT-enabled devices provide real-time data on inventory levels and asset locations, while blockchain technology ensures data integrity and reduces transaction costs through secure, transparent record-keeping. Saburi et al., 2019. Key insight: digital transformation significantly improves operational efficiency and decision-making quality by providing real-time, actionable insights into supply chain operations. Studies confirm that companies adopting IoT and blockchain technologies experience improved traceability, reduced delays, and greater customer satisfaction. Christopher, 2016. Limitations: the adoption of these technologies presents challenges related to high implementation costs, data privacy, and the need for standardized protocols. Blockchain adoption, for example, is hindered by the absence of industry-wide standards, which limits interoperability across different platforms. Saburi et al., 2019. 4.3. Lean and agile supply chain paradigms. The lean and agile paradigms represent 2 major approaches to achieving supply chain efficiency and flexibility. Lean strategies focus on waste reduction, process standardization, and continuous improvement, while agile strategies emphasize responsiveness and adaptability to market changes. Womack et al., 1990, Christopher and Toil, 2001. The literature indicates that a hybrid legal approach, which combines lean's cost efficiency with agile's flexibility, can be particularly effective for industries facing both high demand uncertainty and pressure to reduce costs. Naylor et al., 1999. Key insight: hybrid legal supply chains achieve a balance between efficiency and responsiveness, offering a competitive advantage in markets where demand is unpredictable. Van Hook, Harrison, and Christopher, 2001. Lean principles improve resource utilization, while agile capabilities allow quick adaptation to changes. Limitations: achieving a legal balance is challenging, as it requires a flexible infrastructure and the ability to scale production quickly without compromising cost efficiency. Moreover, firms may struggle to determine the optimal level of legal integration, particularly in highly volatile markets. Aitken, Childerhouse, and Toyle, 2003. For point 4, risk management in supply chains. Effective supply chain risk management, SCRM, is critical for handling disruptions due to unforeseen events, including natural disasters, geopolitical conflicts, and demand fluctuations. Pettit et al., 2010. The review highlights that many companies are adopting advanced risk management frameworks that integrate risk identification, assessment, and mitigation strategies into their supply chain operations. Theoretical models such as resilience theory and risk analytics support firms in developing adaptable and resilient supply chains capable of withstanding external shocks. Ivanov and Dogwy, 2020. Key insight: proactive risk management significantly enhances supply chain resilience. Studies show that organizations implementing comprehensive SCRM frameworks can better absorb and recover from disruptions, thus maintaining efficiency and minimizing losses. Jutner et al., 2003. Limitations: despite the benefits, the complexity and cost of implementing sophisticated risk management frameworks can be prohibitive, particularly for small and medium-sized enterprises, SMEs. Additionally, some firms lack the analytical tools to quantify risks accurately, which limits the effectiveness of SCRM. Sheffy, 2005. 4.5 Sustainability and Green Supply Chain Management. The theme of sustainability is increasingly prominent in supply chain literature, with growing emphasis on environmental impact reduction, resource conservation, and circular economy models. Suring and Muller, 2008. Sustainable supply chain practices include reducing carbon emissions, utilizing renewable energy sources, and implementing closed-loop systems. These practices not only enhance corporate responsibility, but also contribute to long-term operational efficiency. Pagel and Wu, 2009. Key insight: sustainable supply chains can achieve both environmental and economic benefits, as evidenced by studies linking sustainable practices to reduced resource consumption and operational costs. Gold et al., 2010. Additionally, sustainable supply chains improve brand reputation and align with consumer preferences for environmentally responsible companies. Limitations: sustainable practices often require significant upfront investment, and the transition to a circular economy model is complex. Further research is needed to identify scalable, cost-effective sustainable practices that can be implemented across various industries. Linton, Klassen, and Jayaraman, 2007. Summary of key findings. The review identifies data-driven decision-making, digitalization, lean and agile paradigms, risk management, and sustainability as crucial areas of advancement in supply chain efficiency and decision-making. Table 1 provides a summary of these themes, their impact, and common challenges. Table 1. Summary of key findings on supply chain efficiency and decision-making. Theme: impact challenges. Data-driven decision-making. Enhances forecasting accuracy, real-time adjustments. Data quality, system integration, skills shortage. Digitalization and technology. Improves transparency, traceability, and responsiveness. High costs, data privacy, lack of standardization. Lean and agile paradigms. Balances cost efficiency, lean, and responsiveness, agile. Achieving legal integration in volatile markets. Risk management. Builds supply chain resilience and enhances recovery from disruptions. High cost, complexity, and limited risk quantification tools. Sustainability. Reduces environmental impact, operational costs, and aligns with consumer expectations. High initial investment, complex circular economy transition. The systematic review of literature highlights the multifaceted approach required to enhance supply chain efficiency and decision-making. Emerging technologies such as IT, AI, and blockchain play transformative roles, while risk management and sustainable practices address modern supply chain challenges. However, significant obstacles remain in terms of cost, implementation complexity, and scalability. These findings offer a comprehensive overview of current advancements, underscore the practical implications for supply chain managers, and suggest directions for future research, including more accessible hybrid models and scalable sustainable practices. 5. Discussion. The findings of this systematic literature review reveal the dynamic and multifaceted nature of supply chain efficiency and decision-making in contemporary business environments. By synthesizing the latest research on data-driven decision-making, digitalization, lean and agile paradigms, risk management, and sustainability, this discussion section offers an integrative perspective on how these elements contribute to more resilient, adaptable, and efficient supply chains. 5. 1. Implications of data-driven decision-making for supply chain efficiency. Data-driven decision-making emerges as a pivotal enabler of supply chain efficiency, providing firms with enhanced forecasting accuracy, better inventory management, and improved responsiveness to market changes. As shown in prior research, Chai et al. 2014, Ivanov et al. 2019, predictive analytics and machine learning support real-time decision-making, leading to reductions in both lead times and operational costs. However, implementing data-centric approaches comes with challenges, including data integration and quality concerns, and a shortage of skilled data professionals, which restricts the scalability of analytics capabilities across industries. Wamba et al. 2015. Theoretical implication. From a theoretical perspective, data-driven decision-making in supply chains aligns with the resource-based view, RBV, of competitive advantage, where data and analytical capabilities represent strategic resources that drive firm performance. Barney, 1991. The incorporation of data analytics strengthens a firm's capacity to respond to market dynamics and creates a competitive advantage through operational efficiency. Practical implication. Practitioners are encouraged to adopt robust data governance frameworks to ensure data quality and address privacy concerns. Training programs to upskill employees in data science could also mitigate the current skills gap, making data analytics more accessible across supply chain functions. 5.2 Digital transformation, a double-edged sword. Digitalization, enabled by IT, blockchain, and AI, is reshaping traditional supply chain operations, providing increased visibility, traceability, and real-time monitoring. Bendaya et al. 2019, Saburi et al. 2019. However, while digital transformation facilitates operational efficiency, it also introduces new risks, such as data security issues and high implementation costs, which may limit adoption, especially among SMEs. The absence of standardized protocols in blockchain, for instance, presents a barrier to its widespread use, as interoperability issues complicate integration across systems. Saburi et al. 2019. Theoretical implication. The digitalization of supply chains aligns with the concept of dynamic capabilities, which posits that firms must continually adapt their resources and processes to maintain competitiveness. Thies, 2007. Digital technologies not only enhance operational efficiency, but also enable firms to sense, seize, and transform resources to stay agile in volatile markets. Practical implication. Managers should carefully assess the cost-benefit ratio of digital technologies and invest in cybersecurity measures to protect data integrity. Collaborative initiatives to develop industry-wide standards for blockchain could also mitigate interoperability challenges and facilitate adoption. 5.3 Lean and Agile paradigms toward a hybrid, legal supply chain. The literature emphasizes the effectiveness of combining lean and agile paradigms to achieve a balance between cost efficiency and responsiveness, particularly in markets where demand fluctuates. Christopher and Twill, 2001, Van Hook et al. 2001. The legal approach allows firms to benefit from lean's waste reduction and agile's adaptability, creating supply chains that are both efficient and resilient. Theoretical implication. This hybrid approach is supported by contingency theory, which suggests that supply chain strategies must be tailored to align with environmental conditions. Lawrence and Lorsch, 1967. Firms facing stable demand can prioritize lean strategies, while those in volatile markets may benefit from agility, with a legal approach offering a balanced solution in mixed demand contexts. Practical implication. For practitioners, adopting a legal approach requires investment in flexible manufacturing systems and supplier relationships that allow rapid scaling. Managers are encouraged to develop modular production and distribution systems that can easily switch between lean and agile modes as needed. 5.4 Supply chain risk management, SCRM building resilience in uncertain environments. Supply chain risk management is critical to coping with disruptions from events such as natural disasters, political instability, and market shocks. Petit et al., 2010, Ivanov and Dolgui, 2020. The literature supports that resilient supply chains can absorb shocks more effectively, safeguarding operational efficiency and service levels even under adverse conditions. Theoretical implication. SCRM aligns with resilience theory, which emphasizes the capacity of a system to absorb disturbances and retain functionality. Halling, 1973. By embedding risk management processes into supply chains, firms are better prepared to manage disruptions and maintain continuity. Practical implication. Practitioners should consider a multi-tiered approach to SCRM that includes risk identification, assessment, and mitigation measures at each level of the supply chain. Regular scenario planning and investment in risk analytics tools can further enhance a firm's preparedness for potential disruptions. 5.5 Sustainability. Balancing efficiency with environmental responsibility. Sustainable supply chain practices have gained attention as firms face pressure to reduce their environmental footprint. Pagel and Wu, 2009, Soering and Muller, 2008. Sustainable practices, such as waste reduction, recycling, and the use of renewable resources, have been shown to not only benefit the environment, but also enhance long-term operational efficiency by reducing resource dependency. Gold et al. 2010. Theoretical implication. The incorporation of sustainability in supply chains is supported by stakeholder theory, which argues that businesses have a responsibility to balance the interests of all stakeholders, including the environment and society. Freeman, 1984. By adopting sustainable practices, firms can create shared value that benefits both the organization and the broader community. Practical implication. Managers are encouraged to integrate sustainability into supply chain decision-making by adopting circular economy models that minimize waste and promote resource conservation. Investing in renewable energy and eco-friendly materials can also improve supply chain sustainability while aligning with consumer demand for responsible corporate practices. Emerging research gaps and future directions. While significant advancements have been made, this review identifies several research gaps that merit further investigation. Scalability of data analytics. Research should explore ways to make data-driven decision-making more accessible and scalable, particularly for SMEs, by addressing data quality and integration challenges. Standardization of digital technologies. The development of standardized protocols for technologies like blockchain and IT could facilitate wider adoption and interoperability across supply chain networks. Optimizing the legal approach. Further empirical studies are needed to determine the optimal balance between lean and agile practices across different industries and market conditions. Advanced SCRM frameworks. There is a need for research on advanced SCRM frameworks that can integrate real-time analytics and predictive capabilities to anticipate and mitigate potential risks more effectively. Impact of sustainability on profitability. Future studies should investigate the long-term financial impacts of sustainability on supply chains, particularly regarding how circular economy practices influence profitability. 6. Limitations of the review. This review has certain limitations. First, while it provides a comprehensive analysis of 150 articles, the selection was limited to Scopus indexed, peer-reviewed journal articles published in English, which may exclude relevant insights from other sources or languages. Additionally, the scope of the review was restricted to recent advancements since 2010, potentially overlooking foundational works that shaped the evolution of supply chain management theories and practices. Finally, the thematic analysis focused on 5 primary areas, potentially underrepresenting other relevant aspects such as human resource management and cross-functional collaboration in supply chains. The systematic literature review underscores the growing complexity of supply chain management as firms adopt new technologies and strategies to enhance efficiency and decision-making. Data analytics, digital transformation, legal approaches, SCRM, and sustainability emerge as the core areas shaping the future of supply chains. Despite the progress, challenges persist, particularly regarding data integration, cost of technology adoption, and balancing operational efficiency with environmental responsibilities. This review provides a foundation for further research and offers practitioners actionable insights into developing efficient, adaptable, and sustainable supply chains. Future research directions. The systematic review of literature on enhancing supply chain efficiency and decision-making reveals several avenues for future research. As global supply chains continue to evolve in response to technological advancements, economic shifts, and environmental pressures, research in these areas is crucial to further understanding and improving supply chain performance. This section outlines key areas where additional studies could address current limitations and contribute to the ongoing development of efficient, resilient, and sustainable supply chains. 6.1 Scalability and accessibility of data-driven decision-making for SMEs. While data analytics has proven transformative in improving supply chain efficiency, smaller firms face significant barriers, including high costs, limited data quality, and a lack of skilled data professionals. Future research could investigate cost-effective, scalable data solutions tailored specifically to small and medium-sized enterprises, SMEs, as existing tools are often designed for large corporations with extensive data resources. Studies could explore the use of cloud-based analytics, subscription-based data services, and training programs aimed at enhancing data literacy among SME employees. Research question: how can scalable, low-cost data analytics solutions be developed and implemented to enhance supply chain efficiency for SMEs? Research method: case studies or experimental designs focusing on the implementation and outcomes of data-driven tools in SMEs across various sectors. 6.2. Standardization and interoperability of digital technologies. Research question: what are the most effective frameworks for standardizing digital technologies in global supply chains? Chains? Research method: a comparative analysis of existing digital technology standards across different industries, followed by industry surveys or expert interviews to identify best practices for standardization. 6.3. Optimization of lean, agile, and legal approaches in various industry contexts. The literature suggests that a hybrid, legal approach, which combines the cost efficiency of lean practices with the flexibility of agile systems, offers significant advantages. However, further research is needed to determine optimal legal configurations tailored to specific industry conditions, particularly for those with variable demand and complex production processes. Research could focus on identifying the right balance of lean and agile principles for different supply chain environments, thereby providing managers with actionable guidelines. Research question: what are the optimal configurations of lean and agile practices across different industry contexts, and how can the legal approach be tailored to sector-specific needs? Research method: sector-specific case studies examining the implementation of lean, agile, and legal strategies, complemented by quantitative modeling to assess outcomes in efficiency and responsiveness. 6.4 Advanced Supply Chain Risk Management, SCRM, models. Despite the growing importance of risk management, current frameworks often fall short of adequately preparing firms for complex disruptions such as climate change, political instability, and cyber threats. Future studies could investigate advanced SCRM models that incorporate real-time data analytics, machine learning, and predictive capabilities to proactively identify and mitigate risks. Developing models that integrate these capabilities could improve resilience by enabling faster and more informed decision-making during disruptions. Research question: how can advanced analytics and machine learning improve the effectiveness of supply chain risk management? Research method: development and testing of new SCRM frameworks using machine learning algorithms, followed by simulation-based analysis to measure resilience and recovery time in different disruption scenarios. 6.5 Long-term impact of sustainable practices on supply chain profitability. Sustainability is becoming increasingly prioritized, but there remains limited understanding of its long-term financial impacts on supply chain efficiency and profitability. Future research could explore the return on investment, ROI, of sustainable practices over extended periods, examining how investments in green logistics, waste reduction, and renewable energy sources affect both operational costs and firm profitability. This research would provide valuable insights into the economic feasibility of sustainable supply chains. Research question: what is the long-term financial impact of sustainable supply chain practices, and how do they influence overall profitability? Research method: longitudinal studies tracking the financial performance of companies adopting sustainable practices compared to non-adopters, alongside surveys to capture managerial insights on perceived ROI. 6.6 Integration of circular economy principles into supply chains. The adoption of circular economy models, which aim to minimize waste and promote resource reuse, offers significant potential for sustainable supply chains. However, research on how to effectively incorporate circular economy principles at scale within complex global supply chains remains limited. Future studies could investigate best practices for implementing circular systems, particularly in industries with high resource consumption, such as manufacturing and electronics. Research question: what strategies can facilitate the integration of circular economy principles into complex supply chains, and what are the measurable impacts on resource efficiency? Research method: case studies of companies pioneering circular supply chain models, combined with quantitative analysis on resource use, waste reduction, and cost savings. 6.7 Enhancing collaboration across the supply chain ecosystem. Supply chain efficiency and decision-making depend on effective collaboration across all stakeholders, including suppliers, distributors, and logistics providers. Future research could explore how to strengthen collaborative frameworks, particularly in terms of information sharing, joint decision-making, and strategic alignment. The impact of collaborative practices on supply chain performance metrics, such as lead time reduction, inventory optimization, and service levels, warrants further investigation. Research question: how can collaborative frameworks be enhanced to improve information sharing and decision-making across supply chain ecosystems? Research method: surveys and in-depth interviews with supply chain managers and partners across various industries to understand barriers to collaboration, followed by the development of frameworks that facilitate collaborative efficiency. 6.8 Role of artificial intelligence and automation in ethical decision-making. The adoption of AI and automation introduces ethical considerations, particularly as these technologies can make decisions that impact labor practices, customer data privacy, and supplier selection. Future studies could investigate ethical frameworks for AI in supply chains, particularly around ensuring transparency, fairness, and accountability in AI-driven decisions. Understanding the social implications of AI and automation is essential to guide responsible technology use in supply chain management. Research question: what ethical frameworks can ensure transparency, accountability, and fairness in AI-driven supply chain decision-making? Research method: development of a theoretical framework based on ethical decision-making principles, followed by case studies of AI implementation in supply chains to assess its impact on ethics and compliance. 6.9 Impact of globalization and geopolitical dynamics on supply chain resilience. The ongoing shifts in globalization and emerging geopolitical challenges have significant implications for supply chain resilience. Research should focus on how global political changes and trade policies influence supply chain design and decision-making. Specifically, studies could analyze the effects of reshoring, nearshoring, and localization strategies on efficiency, costs, and resilience. Research question: how do geopolitical dynamics and shifts in globalization impact supply chain resilience and decision-making? Research method: comparative analysis of firms that have adopted different geographical strategies, e.g., reshoring versus nearshoring, and the subsequent impacts on resilience and operational efficiency. The proposed future research directions outlined above reflect the evolving landscape of supply chain management. By addressing these critical areas, such as scaling data analytics for SMEs, optimizing legal strategies, advancing SCRM models, and integrating circular economy principles, scholars and practitioners can better navigate the challenges posed by technological, economic, and environmental changes. Addressing these gaps through empirical research, theoretical framework development, and industry collaboration will not only enhance supply chain efficiency and decision-making, but also build more resilient and sustainable supply chain ecosystems.